Assalamualaikum warahmatullahi wabarakatuh and very good day. This video is a continue from the first video about half-wave rectifier uncontrolled with HWRload. As we have discussed before and on the first video, we will look in detail how to do the simulation on the schematic diagram for the half-wave rectifier uncontrolled with HWRload. Okay. Before that, I would like to refresh again the example that we have discussed in the class. Example 1, which is considered the half-wave rectifier circuit with a resistive load of 25 ohm and a 60 Hz AC source of 110 volt RMS value. Okay, so how we want to setting this parameter in the MATLAB in order to perform the analysis of the half-wave rectifier uncontrolled with HWRload. Okay, now we go to the first part of the setting by click the symbol of the block parameters of AC voltage source. This is the default setting by the AC voltage source for a block parameters for the AC voltage source. The peak amplitude, phase diagram, the frequency and the sample time. So the question provide 110 volt RMS, but the setting value at the block parameters is 110. So 110 RMS, so we need to multiple the 110 volt RMS with set 2, we obtain 155.56 volt. We remain the phase in degree unit is 0, the frequency and the unit hertz is 60, and the sample time will remain 0. And then we apply and click OK. Right, and then we click the default for the block parameters for diode. We obtain the resistance 0.001 ohms, which is represent the internal resistance for the diode. Inductance will remain 0. For voltage, if we choose that this is the ideal case, we put the value for fault voltage as 0. Okay, and we remain for the snubber resistance as well as the snubber capacitance as recommended or default by the MATLAB. Okay, and then we go to the setting for the HWRload. The default value is 1. We change to 25 ohm. Click apply and OK. Right, and the question asks to calculate the average value of V out and I out. Okay, we will do the first part of the question to identify or to calculate the average value of V out and I out of the system. Okay. So what we need to do now is to obtain the proper measurement tools that we can determine or we can get from the Simulink library browse. Okay, so the familiar measurement component that we need to use is called a scope. We go to the search area here, and then we tap scope and then enter. Okay, the scope is under the Simulink tools for the sync. Yeah, for the sync. There is two type of scope called floating scope and scope. So you choose scope and then add to your file. Okay, sorry for the delay because my laptop is a bit lower the RAM. Okay, so we put the scope here and then add the source as well as the output. The next measurement tools that is important is I want to measure the voltage and the current. So we need to apply for the under Sim Power Systems tools. So we choose measured. We need to find the voltage measurement. So as well as the current measurement, because we need to measure the average output voltage as well as the average current average output current. Okay, so you can delete the name, the labeling. Okay, now we can rotate in order to arrange our setting component. So this is where I want to measure my voltage input. So measure here. Okay, just copy to measure your output voltage. So you can put here, you can put here as well. So current, we need to connect in a series with the components. Just copy, just drag. By drag the component, the purpose to drag the component will make the symbol or the components become duplicate. You duplicate the components by drag the component. Okay, so save the file. So now the frequency is 60 Hz, meaning that if I have the component F equals to 1/T, so in order to have period equals to 1/F, meaning that 1/60. So this is represent 1/60 meaning that 1/60 you have 0.02 for one period. Okay, roughly 0.02. Okay, so this is whereby you need to setting your simulation stop time here. If you put 0.02, meaning that you only simulate the schematic diagram for one period. So this is not practical because you cannot see, or very difficult to see the performance in one period. So I recommend you to have the 3 period 0.02 times 3 0.06. okay. So now we just want to know, we still not answer the question yet. Okay, we just want to know whether the system is workable or not for the setting that we have performed just now. So by click the start simulation button here. Okay, it show some error here. Okay, meaning that it say that the initialize command cannot be evaluated. Okay, so what you need to add in this type of error is by adding the power GUI block, because in MATLAB Simulink the system is in the form of GUI, graphic user interface. So what you need to do, go to library browse, find the block called power GUI and enter. Okay, so power GUI, just copy this block, add to your file. Okay, just put any corner that suitable. Remain on the continuous mode, click save button again, and then perform your simulation. Okay, so your setting is okay, meaning that there is no error is appear. Okay, so now we look at the graph. When you click the scope button, it always show the default setting. So what you need to do, click the button called auto scale. So auto scale meaning that we will perform automatic scaling. Okay, this is whereby you can see this is for 1, 2 and 3 cycle, 3 cycle or more, 3 cycle and more. Okay, but this is for the input voltage. Okay, can we see for the output voltage? Since this is the half-wave rectifier, our expectation for the output voltage is we cut off at the negative cycle. So ideally we perform the half-wave rectifier concept. Okay, half-wave rectifier concept we perform already. So now if we look at the back, the peak value, this is the peak value of the input voltage. It determined 155.56 volt. Okay, roughly. Okay, so it follows based on our setting. Okay, and the output voltage for the DC value of voltage, so it remains the same output voltage, since this is an ideal case, ideal value. Okay, so now we want to find the average value of output voltage and output current. Okay, output voltage and output current. So in MATLAB when we talk about the average value, meaning that the block is called mean. Okay, mean. So the mean, you type the mean and you choose the Simscape mean value. Okay, mean value. So mean value, you need to copy to resizing the mean block. You double click, and normally the average period based on your frequency. Since our setting frequency at the source input is 60 Hz, meaning that the averaging we need to setting 1/60. If we set the source voltage fundamental frequency is 50 Hz, so in this function block parameters, the mean value we need to set 1/50 Hz. Okay, then we click OK. Since we also need to determine the input, output current, so we need to copy the second block of the mean parameter. So in order to locate the mean block to the output current as well as the output voltage, you just bring the block and put in the middle of the wires. Okay, you can resizing them, right? So based on our discussion before, we have determined the average value of output voltage and output current is 49.52 and 1.98 amp respectively. So now we start the simulation. So we determine the average output current. Roughly we obtain at the 1.98 amp. Okay, if you want to resizing the thickness of the line, you just go to the style and increase the size here. Okay, so the size 1.98 amp. Okay, so now we go to the output average output voltage. Auto scale, setting the sizing 3. We almost get the answer for average output voltage at 49.5 volt. Okay, so I hope you can try this setting in your MATLAB laptop. So, and then if you have any question or any difficulties about the setting, you can determine, or you can ask question via WhatsApp group, especially on the release 2012A. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.